Okay, we're going to continue talking about our exponent rules. Okay, so first of all, we've got another rule about the zero exponent. Okay, anything to the zero power equals 1. Anything to the zero power equals 1. So need a pen. 38 to the zero power equals 1. I just need to memorize this rule. Okay, x to the zero power equals 1. Anything to the zero power equals 1. Now, be careful about these two. Remember, we talked about this last time. This means the whole -9 is raised to the zero power. So -9 to the zero power equals 1. I just realized I said 1, but I put a 0 right there. Okay. So anything to the zero power equals 1. Anything to the zero power equals 1. But this is not -9 to the zero power. This is only 9 to the zero power, right? This negative has nothing to do with that 0. So that negative stays. And then 9 to the zero power is 1. So be careful about that. Same thing here. This 5 does not have an exponent on it. It has nothing to do with that 0 power. So this is 5 times 1 because x to the 0 is 1. But right here, 5x, the whole thing, is being raised to the 0 power. Anything to the 0 power is 1. Okay. Now, negative exponents. Okay, negative exponents mean reciprocals. Negative exponents have nothing to do with negative numbers. Notice this has a negative exponent and my answer is not negative. Negative exponents have nothing to do with negative numbers. Negative exponents have nothing to do with negative numbers. To get rid of a negative exponent, we use the reciprocal. So I want to think about a fraction. If I don't see the fraction, make it a fraction. And to make any negative exponent positive, you just change its place in the fraction. So if it's in the numerator, I flip it to the denominator and it becomes positive. If it would have been in the denominator to start with, I flip it to the numerator and it becomes positive. Okay, negative exponents mean reciprocals. Reciprocals mean you flip your fraction upside down, remember? Negative exponents have nothing to do with negative numbers. Okay, so this means this is 1 over 9 cubed. 9 to the positive 3. And then 9 times 9 is 81. And 81 times 9 is 729. Not a negative number, a fraction. Okay, I've got a negative exponent. Negative exponents mean reciprocals. So the reciprocal, and because it's on parentheses, it goes to the 1 and the 4. So the 1's going to flip to the denominator, the 4 to the numerator, or the reciprocal of 1/4 is 4. 4 times 4 is 16. 16 times 4 is 64. Okay, so what about this one? Yeah, I just flipped that 2/3 to 3/2, and then it's all to the 5th power. So now I use the property from last time, which means everything inside the parenthesis gets the exponent. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Go over to the side and write it down if you need to. 2 times 2 is 4, 8, 16, 32. Okay, be careful. I have no rules for adding and subtracting. No rules for adding and subtracting, right? I have to do these individually then. This is 1/6 minus 1/3. Now, it's just two fractions, so in order to add those, I need a common denominator. So this is 1/6 minus 2/6. Now that the denominator is the same, it stays the same. So 1 minus 2, negative 1/6. Okay, this is just telling us that negative exponents lead to reciprocals. A negative exponent does not indicate a negative number. Negative exponents are not negative numbers, and it's just showing us an example, right? If this number started out negative, it stays negative. If it's positive, it stays positive. The negative exponents mean reciprocals, not negative numbers. Okay, this one's just basically telling us the same thing. A negative exponent, to make it positive, it means the reciprocal. And then we have our quotient rule. If you're dividing two exponential numbers with the same base, you can subtract their exponents. Remember our product rule. When you're multiplying two exponential numbers with the same base, if you're multiplying them, you add the exponents. If you're dividing them, you subtract the exponents. Okay, now think about what this means. This means this is 5 multiplied times itself 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And on the denominator, it's a 5 multiplied times itself 5 times. So if you're just multiplying, anything in the numerator and denominator can cancel out. Anything that's the same, right? And notice, oh, that leaves 3 5s. Oh, there's 6 5s in the denominator, it says 6 5s. So notice that leaves 2 5s. So this is what I want to think about. Oh, how many of them can cancel out? If it had been written the other way around, I could still do my subtraction. This would be 5 to the 6 minus 8, right? But then I've got to use that other rule about negative exponents. So something I can do is just think about if I'm dividing exponential numbers with the same base, they got to have the same base, then I can think about, oh, how many is going to cancel out? And right here, if there's 6 of them on top and 8 of them on bottom, I know that 6 of them are going to get to cancel out. So 2 of them are going to be left in the denominator, which is going to be the same thing as this, but it saves me a step if I want to think about it that way. Okay, oh, they're just showing you what that means. Okay, oh, and here they're telling you to be careful. This is a good idea, right? We're not canceling the 2 5s, right? I'm canceling 8 5s and 6 different 5s. So 2 of the 5s remain. Be careful about that. All right, so let's think about this. If there's 4 3s on top, let's do it one time. And there are 6 on the bottom. What's going to happen is, oh, and if everything in the numerator divides out, remember it's a 1. And then there's 3 times 3 on the bottom. Okay, negative exponent. So first, before I do anything, my first step is always get rid of those 0 exponents and negative exponents. So first step is I've got to flip these. I'm only flipping both of them because they both have a negative exponent. I'm only moving whatever has a negative exponent to make it a positive exponent. Hey, now there's 9 y's on the top, so it's a bunch of y's, but there's only 2 on the bottom. So 2 of those y's are going to get to cancel out. 9 minus 2 is 7. Negative exponent, I got to do that first. Nothing else is going to move. Nothing else is going to move. But that -5 needs to be positive. Okay, nothing else has a negative exponent, so they stay. All right, now I'm multiplying two numbers that have the same base, so I add the exponents. Remember what that means. Here's 4 of them multiplied together, 2, 2, 2, 2, times 5 more. 4 and 5 are 9. Now, these are the same base, z plus a and z plus a, that's the same. So if I have 7 of them on the top and 6 of them on the bottom, 6 of them are going to get to cancel out, and there's just going to be 1 left on the top. Now be careful, plus sign, don't do it, right? Be careful. I cannot distribute that over a plus sign. I'm done with that. I'm finished. This is not z to the 7th plus a to the 7th because it's a plus sign. Only multiply and divide. Okay, what's the first thing I would have to do here? Yes, sir. Get rid of negative exponents. So this would be 5 y, and this has a negative exponent, so let's move it to the top. Okay, this has a negative exponent, so let's move it to the bottom. Okay, now I've done the 5, I've done the x to the -3, so there's a y to the 8, it's left on the top. Okay, x to the 4th, y to the 6 on the bottom. Okay, I cannot multiply that 5 times 3. I got to do the exponent first. Remember your order of operations. Exponents first. So this is 5 times 9. Okay, now I've got 8 y's on the top and 6 on the bottom. So 6 of them are going to get to cancel out, and that's going to leave 2 y's on the top. 3 x's times 4 more x's is altogether 7 x's. 3 plus 4 is 7. I still have some math I can do, so I'm not finished yet. 9 times 5 is 45. Y squared, x to the 7th. Okay, so here is a list of all of the rules. It takes up 2 slides, so you might want to write this down somewhere to have until you memorize them and to use while you're doing your homework. I gotta know these rules for my test. Okay, the product rule, the zero exponent rule, the negative exponent rule, the quotient rule, and now here's the power rules and some more negative exponent rules. So let's practice one last time. Okay, so first thing, I'm going to get rid of these parentheses. So I can't do this yet because this is not really 2 cubed. It's in parentheses. So 3 times 2 is 6. Oh, anything divided by itself is 1, right? Or I could say 6 minus 6. I don't know why I put that there. Okay, and anything to the 0 power is 1. But anything divided by itself, 2 to the 6th, 2 to the 6th, is going to be 1. And that's why anything to the 0 power is 1. Okay, let's get rid of parentheses. So don't forget that 3 gets that exponent of 4 also. 3 to the 4th, y to the 4th. times 3 squared y squared. Okay, and this has a negative exponent, so it flips up to the top and is whoops. Come on, pen. And is 3y to the positive 1, okay, which is just 3y, right? So now I don't even have anything in the numerator. So all of these are the same, and that makes this 3. I'm going to just rewrite this so that we can see, get that last bit out of the parentheses. If it's just 2 to the 1, it stays 3y. Okay, so I have 3, 4, 5, 6, 7 of those 3's, and then 4, 5, 6, 7 of those. Hopefully they won't make you do 3 to the 7th if you get a number that big, right? But typically, and on the test, you won't have a number with an exponent that big. But any numerical value that has an exponent, you got to multiply out. Okay, so let's work inside parentheses first. Inside parentheses, this has a negative exponent and this has a negative exponent, so I've got to do negative exponents first. Negative exponents first, so that's 2 to the 1 moves to the top, and then a to the negative 3 moves to the bottom to make that positive. Now, I haven't even done anything with this exponent yet, right? Just working inside parentheses. But I'm still working inside parentheses because here's some math I can do. So that would be 10, and then a cubed b to the 4th. Okay, now when there's nothing left to do inside the parentheses, now I look out here to do this exponent. Oh, it's negative. It's on parentheses, meaning it goes to everything in there. So everything in there has a negative exponent. Everything in there has to change places. Negative exponents mean reciprocals. They have nothing to do with negative numbers. Now that made that exponent positive. Now I can distribute it to everything in there. So if I've got an exponent raised to an exponent, I multiply. 3 times 2 is 6. 4 times 2 is 8. And 10 squared is 100. Okay. Let me know. Go get some practice.